The purpose of this video is to go over problem number 71. I didn't feel like it was a clear explanation during the class the other night, so I wanted to just take a minute to go over it. So this is chapter 9, problem 71, and it's about the Silicon Valley firm. First thing that you need to do is get the data. You got to somehow come up with ones for females and zeros for males. Once you've done that, then you're going to need to sum both of these columns. So I've already summed this one, and I'm going to sum this over here by going to data. I gotta slide it over here so you can see it. So we're going to go to the home tab and then to auto sum, and we'll get this. So 19 for the males and females. Okay, so now we're going to go back up here and we're going to take a look at what the problem says. It says that we need to determine at the 5% significance level if the proportion of women in Tara's firm is different from 30%. So the 30% is the P bar for us. So we need to annotate that. So I just went in and annotated it using the equation editor. P bar is equal to 30%. So P bar is what we're that's the average for the population, so that's what we're comparing it against. Now we also need to annotate our group, which we're looking at first in part A is the females. So we need to compute the percentage of females in the firm, so we're going to do that like this. So the percentage of females is going to be 19 divided by 50, which is 38%. So 19 divided by 50 is 38%. So now we can set up our Z table computation, because what we want to do is determine if our value of 0.38 is sufficiently distanced from the mean in order to say that it is statistically different than the other number of 0.30. So in order to do that, we have to do a couple things. We're going to have to do this Z calculation, but we also know when we do our Z calculation, we need to calculate the standard error for P. And there was a lot of question in class about what to call this denominator, and I tried to explain in class that it is called the standard error of P. It's just like a standard deviation, but if you want to be technical, the proper name, standard error for P. So we need to calculate this value. We also need to set up our hypothesis test. So we have several things in front of us that we need to do for this problem. If we want to start by setting up the hypothesis test, because that's always a great place to start, well then in that case we want to make sure that we've written it out correctly. So let's go ahead and do that together. So here we are with our two hypotheses. We've got HO. The null hypothesis is that P, our proportion that we're interested in examining, is indeed equal to 30%. And our alternative is that P is not equal to 30%. So now we need to calculate the standard error of P so that we can then calculate our Z computation. So right here, we'll put the calculation for the standard error for P right here. We have the standard error of P is calculated as P bar times 1 minus P bar, because with P we have a proportion of defects, and with the proportion of defects we only have the event occurring or not occurring. That's where the 1 minus P comes from, and we need to divide by N, which we know is going to be 50. So we've got 0.3 times 1 minus 0.3, or 0.3 times 0.7 divided by 50, and we should get this value right here, 0.065. So this is our standard error for our P bar. So now we can go about calculating the Z computation. So we'll take this formula here and we're going to copy it down here, and we can just do the same thing again, right? Instead of using this, we'll just copy it. So we'll calculate our Z calculation here by taking our calculated P value right there, this 0.38, subtracting off of that our P value that we previously had used as the population average. and we'll divide through by our standard error of p. And this gives us 1.23. Now this value here is actually our z value that we're going to need to then look up on a chart. There was a lot of discussion in class and a little bit online, and that was about whether or not we could do this using an Excel function. So I looked through the book, and I also looked at a few things on Excel, and I was not easily able to obtain a Excel function that does exactly what we need to do in this case. So instead, I'm going to show you on a Z table. Now, if you would like to find the Excel function that allows you to do this, you're welcome to do that. The one thing I will tell you, though, is that you can't highlight the array in this case because the array has no normal distribution. We have only zeros and ones because we're using something called a proportion of defects. It's not a t-test. It's a z-test, and we need to look up this value right here. So that's what I'm going to do. And you can see I brought over this table, and I'm going to look at 1.23. So 1.23 is going to be right here, and that's going to return the z value of 0.8907. So what this tells us is, I've tried to draw here, so let me explain my drawing. So we found a z value of 1.23, which suggests our value, our 0.38, is about right here on the normal distribution. It's not quite two standard deviations, actually. It's 23% more than one standard deviation. So I sort of drew it here with this purple arrow. And I placed 0.038 right here. So notice, in the middle I've got 0.3, that's the mean, the average percentage of females in Silicon Valley firms. Then I went up one standard deviation here, and I wrote out 0.365 because that is the mean plus one standard error. And then this is plus two standard errors plus three standard errors. So our value falls in between 1 and 2 standard errors, so that's where it is. I noted it on here. And then I also drew this do not reject the null, reject the null, this sort of twisted arrow. So if our value falls outside of 1.65, because that's the critical value for 95%, if it falls outside of 1.65, then we reject the null. If it falls inside, we do not reject the null. So one question that I asked when I learned all this was, okay, all that's great, but where does this z value of 1.65 come from? So in the problem, they told us that we wanted to determine this at the 5% significance level. So what I did was I went and looked in the body of this chart for 0.95, and I find it right here at 1.65. I find, well, very close to 0.9505, so that's good enough for me. So that is the rejection region. If our z value is greater than 1.65, then we can reject the null. And if our value is smaller than 1.65, as in our case, which is our value is 1.23, we cannot reject the null. So in the answer to problem A would then be do not reject the null, because we don't have sufficient evidence to be certain that our average number of females is actually different than the Silicon Valley average. All right, so I hope this clears up part A. Now let me move on here to part B and go through that one a little bit quicker because it's basically the same idea. All right, so for this problem, I just copied the data over to this other sheet just because it was easier than messing with the other thing. So anyways, the way the problem is worded, it says at the 5% significance, determine if the proportion of whites in Tara's firm is more than 50%. So I needed to label it such that the whites were 1 and the non-whites were 0. So I did that, and I need to compare my new P, which is going to be the percentage of people that are white, which is going to be 32 divided by 50. So I can do 32 divided by 50, and I get 64%. So what I want to know is if 64% is the same as 50%. Now, of course, it looks a little different, but we need to go ahead and calculate all the same stuff that we did before. And so I'm just going to do that. And if you want to pause this and calculate it yourself and then compare it to what I have, that'd probably be ideal. So let's get that done. We're going to calculate the standard error for P, 50%. And we're going to also calculate the Z computation, which is going to be the difference between 64 and 50 divided by the standard error of P. And when we calculate the standard error of P, we're going to use the 50% because we always use the population, the what is, to calculate the standard error. So I have gone ahead, I've calculated the standard error of P. I've come up with 0.071. That's the amount of variation we expect around the mean. I calculated the Z-score here. I've got 0.64 minus 0.5, and I get 1.972. Then I go look at that here on my Z table, and I find that Z should equal 0.9756 because I just dropped down on here to 1.9, which is here, and then across to the 7, which is here. So that gives us 0.9756. I don't know if you could see that, so I just moved it over here. Right there. Here it is. And then I tried to convert over my little diagram here so that you could see the normal, how it looks on the normal distribution. So basically the middle is 0.5, and then I added 0.071 to here to get 1 standard deviation, 2 and 3. And then I found my value, which was 1.972 when I did my Z computation, and it is outside of my line, so therefore I reject the null in favor of the alternative, which we stated as right here, P is equal to 50%, so that's the assumption that our population is no different than the normal population. And what we're trying to do is show that the alternative is actually true, which is P is not equal to 50%. So because we are able to reject the null in this case in favor of the alternative was correct. So this explains chapter 9, problem 71, and I hope it clarifies some things so everybody is all set on this. Okay, thanks. Have a good one. Bye.